In the previous video, we've learned that exterior alternate angles are equal. Now, in this video, let us establish one last such relationship between a pair of angles. For this one, let us choose these two angles. Now, these two angles are not corresponding angles, and these two angles haven't been covered in any of the previous videos. Now, if you look closely, these two angles lie on the same side of the transversal and they are interior to the two parallel lines, right? So, of course, because they're interior, they must be known as interior angles, and because they lie on the same side of the transversal, we call them interior angles on the same side of the transversal. Right? So, these two angles are known as interior angles on the same side of the transversal. Now to establish a relationship between the two angles, I need a third angle, this one. Now, as usual, let me quickly assign a few variables. Let's call this x, y, and z. Now, in this particular case, I can see that uh, z and y together form a linear pair. So that's the first information that I can infer from this figure, which is angle z plus angle y equals 180 degrees. Why? Because they form a linear pair, right? You can see that this is the linear pair that they form uh, on the straight, they form a straight angle, right? Apart from this, I can also see that angle Z and angle X are corresponding angles, right? This red angle and this red angle are corresponding angles. Therefore, I can write that angle Z is equal to angle X. Why? Because there are corresponding angles. Perfect. Now, instead of writing Z here, I can substitute it with X. Why? Because Z and X are equal. So I'll just substitute them down here. Instead of writing Z there, I'll write angle X there, right? Angle X plus angle Y must also be equal to 180 degrees. That is simple substitution, right? Now, what does this statement mean? Angle X is this angle and angle Y is this angle. So, these two angles together add up to 180 degrees. That means they are supplementary angles. So, essentially, what I've proved here is that interior angles on the same side of the transversal add up to 180 degrees. Now, the same can be applied to these two angles, this angle and this angle. Why? Because these angles are also interior angles and they also lie on the same side of the transversal. They just lie on the other side of the transversal, right? That is the second pair of interior angles on the same side of transversal. And so this angle and this angle must also add up to 180 degrees. So the bottom line is that interior angles on the same side of transversal add up to 180 degrees.